All right, in this video, we're going to look at trig derivatives. So the first one we're going to look at is the graph of sine of x, which is this curve. I hope you're familiar with it. You learned it in pre-calculus. Starts at 0, runs to 2 pi, and it's sort of this backward shape S is how I remember it. And of course, if we're looking at a derivative, we're looking at the slope of the tangent line. And so way over here, we have a minimum. That means our tangent line slope is going to be 0. Here as well, here, and here. So let me draw those in real quick. And then this little piece right in here, this slope is 1. If you were to draw a tangent line to the graph, your slope would be 1. And this little piece right here, your slope is going to be -1. And see the graph. And then, again, a +1 slope. If we plot those values on the same graph, so we're going to plot 0, +1, 0, -1 right here, 0, +1, and 0. And then let's connect with a smooth curve. We can see that the derivative of the sine, sorry, not a very smooth curve, the derivative of the sine curve is the cosine curve. Remember, cosine has a y-intercept of 1, and it's this pretty parabolic shaped graph. The period is 2 pi. And so we can see that the derivative of sine x is cosine x. Pretty cool. Now this is one that you are going to need to memorize. All right, I've done the same thing with our cosine curve. Let me just show you connecting the dots here. And what graph do we have here? Okay, so what graph has a y-intercept at 0, and then it's down, up, and around? Well, of course, that would be our negative sine x. So the derivative of cosine is negative sine x. Okay, so let's do tangent next. Tangent we can think of as sine over cosine. So this is going to be d dx of sine x over cosine x. And if I ever drop the x, that's on accident. It needs to be there. So I'm just forewarning, it's happened. All right, and so when we're taking the derivative of a quotient, well, we use the quotient rule. And I'm going to write this every time because, guys, you have to memorize it. It's bottom times derivative of the top minus top times derivative of the bottom over the bottom squared. All right, so bottom times derivative of the top. We just learned that the derivative of sine x is cosine x minus the top times derivative of the bottom. And we just learned that the derivative of cosine is negative sine x, all divided by the bottom squared. So cosine squared x. When you square this, all of these are equivalent. So just know that when you're squaring cosine, usually you'll see the exponent right here, but that's what you're doing. You're squaring cosine. All right, so in our numerator, let's clean this up a bit. We have cosine squared x plus sine squared x. Okay, think back to your pre-cal days. Who is this? Well, of course, this is our Pythagorean identity. Cosine squared x plus sine squared x is equal to 1 over cosine squared x. And, of course, 1 over cosine squared x is equal to secant squared x. So the derivative of tangent is equal to secant squared x. Here's another one to memorize. At the end of the video, I'm going to show you a link to a video where they have like some shortcuts. So our next one is secant, and this is the reciprocal of cosine. And again, we've got the quotient rule. This one's going to be nice, though, because when we take the derivative of the top, we have a constant here, and so the derivative is 0. And so that's going to kind of simplify our process here. But just to make sure I know this rule. It's bottom times derivative of the top minus top times derivative of the bottom, bottom squared. Okay, so let's see, bottom cosine x times derivative of the top, 0, nice, minus the top times derivative of the bottom over the bottom squared. All right, so this is going to be sine x over cosine squared x, which is sine x over cosine x times 1 over cosine x. You remember all those trig identities from pre-cal? Well, they're coming into play right now. So sine over cosine is tangent x, and 1 over cosine is secant x. So the derivative d dx of secant x is equal to tangent times secant. All right, next up is cosecant, and this is the same as 1 over sine. Quotient rule, bottom derivative of the top minus top derivative of the bottom, bottom squared. Okay, so we have bottom derivative of the top minus the top derivative of the bottom over the bottom squared. And let's see, negative cosine x over sine x times 1 over sine x. I went ahead and just separated in this step. This is going to give us, of course, that the derivative of cosecant x is negative cotangent x times cosecant x. Man, we are just flying through these. You can always pause the video, come back if I'm running too fast. All right, cotangent. That is cosine over sine. Quotient rule. You write it about 10 times, you're going to know it. Bottom, derivative of the top, minus top, derivative of the bottom, bottom squared. Okay, so let's see bottom. Derivative of the top, cosine is negative sine x, minus the top, times derivative of the bottom. Okay, so we're going to get something similar to Pythagorean, except for this time it's going to be negative. Okay, so how can I make this Pythagorean? Well, that would be by factoring out a negative 1. Now the numerator is negative 1 times 1 over sine squared x. So we have negative 1 over sine squared x, and that is cosecant squared x. So I'm going to say the derivative d dx of cotangent x, the derivative of cotangent is equal to, what is that, cosecant squared x? Negative, almost dropped the negative, don't drop the negative. All right, so now let's take a look at a couple of the inverse identities, inverse trig identities. This first one, and it's going to work a little different. I wrote the steps down over here, and the process is here. I'm just going to kind of read through it. It's not as quick as the other ones. So this notation here, tangent to the negative 1 of u, also can be written, this is also called arctangent or arctan of u. And so what we're going to do is, first step, take the tangent on both sides. So if I take the tangent on this left side and the tangent on this right side, what I've got is tangent y is equal to tangent times inverse tangent of u. Okay, so this tangent times inverse tangent, well, those are inverses, so they equal, the product is 1. And so then I have tangent y is equal to u, which is what you see right here. Okay, then the next step is we're going to take the derivative on both sides. So du dx, the derivative of u with respect to x on the left and the right side. And dx of u is just this guy right here. We just found the derivative of tangent to be secant squared. Now, since this is a chain rule right here, we have a function within a function, y, we have to multiply by the chain, of course. So that's why we have that dy dx. All right, so then the next step is to solve for dy dx. So just divide both sides by secant squared y. And so we have dy dx is equal to du dx over secant squared y. Now, we're going to substitute a Pythagorean identity. So here's our Pythagorean identity. Sine squared y plus cosine squared y equals 1. If we divide everything by cosine squared y, we get tangent squared y plus 1 is equal to secant squared y. Let's make a substitution right here for secant squared y with the tangent squared y plus 1. And here is our identity. So dy dx is equal to du dx of 1 plus u squared. Now remember, tangent squared y, from up here, u is equal to tangent y, so 1 plus u squared. It's also written like this. Okay, similarly, arc sine works the same way. We solve for u by taking the sine of both sides. We take the derivative with respect to u. We solve for dy dx, which is right here, by dividing. And again, we're using a Pythagorean identity to make this substitution. So sine squared plus cosine squared is equal to 1. Solve for cosine squared, take the square root. Cosine y, here's the substitution. And there it is. That is your trig identity. All right, so let's work some problems now. Okay, so this first one, we have y equals sine 4x squared. All right, we got the chain rule here. So the derivative of sine, of course, is cosine. And then the derivative of the inside function, there we go. You must apply the chain rule. Leave it like this. I'm perfectly happy. We'll give you full credit. You start moving things around, then you're making me do more math. Same with your AP graders. They can easily see you understand the calculus right here. Of course, if it's a multiple choice, you might have to simplify it, and you can rearrange. All right, so what do we have here on this one? Looks like product rule. All right, so what is product rule? It's first times derivative of the second plus second times derivative of the first. Okay, so that's product rule. I always write my rules. If you just get in the habit of doing them, first of all, you've got a pattern to follow and less likely to make a mistake. And I don't want to lose any points by making a mistake. Okay, and so we've got the product rule, and then we have the chain, because each of these has an inside function. Derivative of 2x would be 2, derivative of 5x would be 5. So just keep that in mind. All right, so first, here's our first factor, sine 2x first times derivative of the second. Derivative of cosine is negative sine 5x times the chain plus the second times derivative of the first. Derivative of sine 2x is equal to, what is that, cosine 2x times the chain. Hey, I'm perfectly happy like this. Now I know some other teachers might say, ooh, let's go ahead and combine the 5 and the negative, move that out front. Can we combine these two though? That would be no. This is sine of 2x, this is sine of 5x. These, the parentheses are different, so you can't combine them. So maybe negative 5x sine 2x sine 5x plus 2 cosine 5x cosine 2x. I don't know. Either one of those is fine with me. Okay, we have, looks like, quotient rule with chain rule. So quotient rule, bottom, derivative of the top, minus top, derivative of the bottom, bottom squared. Okay, so let's see. Bottom, tangent, dang, what's the derivative of tangent? X is equal to, gonna look this one up, guys. I don't have them memorized. I should though. Tangent is secant squared. Okay, and while I'm here, let me look up secant x. Secant is tangent x, secant x. I promise to do my homework. Gonna remember those. It's okay. We can just use some flashcards. I'll be ready by the test. All right, so let's see. Bottom times derivative of the top. We said the derivative of dy dx of secant, dy dx of tangent. There we go. So derivative of bottom times derivative of the top, derivative of secant is tangent x secant x times the chain. And oh, I just made a mistake. 2x secant 2x. Let me clean this up just a bit. I left out the darn 2x. Okay, so let's see. What is that? Bottom times derivative of the top. Tangent 2x secant 2x times 2. All right, I'm back on track. Bottom times derivative of the top times the chain minus the top, and I'm going to have to move over here, times derivative of the bottom. Derivative of tangent is secant squared 2x times the chain. All divided by, okay, that's on my numerator in 2 rows, the bottom squared. All right, so I am going to rewrite this just to clean it up so it's on 1 row. So this is equal to, and I'll go ahead and move this 2 up front. We usually see our coefficients, see our those factors in front. So let's see, we got 2 tangent, I got 2 of these guys. So that would be tangent squared 2x secant 2x. That's that first term minus, and let's see, we got some good stuff here. Okay, we got 1 secant 2x, and we got 2 more secant 2x. Let's go ahead and combine those. I'll bring that 2 up front, this 2 right here, bring it up front, and then this is going to give me secant cubed 2x, all divided by tangent squared 2x. There we go. Final answer. Okay, let's take a look at one with a inverse, and gonna just write this down. Tangent inverse of u is equal to 1 over 1 plus u squared du dx. Remember, this is the chain rule. Derivative of u with respect to x. So this is the inside function. All right, and so in this case, our u value is equal to sine x. So I'm going to go ahead and just indicate that our inside function is equal to sine x. And what is the derivative of sine x? Well, that's cosine x. So let's go ahead and write this. 1 over 1 plus u squared times derivative of u dx, which is cosine x. So it can be written like this, or if you want to go ahead and put it together, we can put cosine x 1 plus sine squared x. Either one of those is just fine. Okay, we have an arc sine. Remember, this is just the same thing as y is equal to sine inverse 3x plus 1. Hey, right there, there's your u. What's your du dx? Oh, 3. How nice. All right, so just a reminder, what is the derivative of sine, the inverse or arc sine of u? Well, that is equal to du dx over square root of 1 minus u squared. All right, so let's see if we can figure this out. What is du dx? That's 3. So that's my numerator. 1 minus u squared. Well, u is equal to 3x plus 1. So this is 3x plus 1 squared. and the square root of. Okay, next one, sine squared x. Well, this is the same thing as sine x squared. So can we do the power rule with the chain rule? Yes, absolutely. So let's see, the derivative, the outside function would be x squared. The inside function is sine x. So this is 2 sine x times derivative of the inside function. There we go, done. Don't forget your chain rule. And I think we have, that's it. That was our last example. All right, so then here is the little video on remembering trig derivatives. Let's see if I can get it to work. I don't know. Why are you not working? Bummer. Oh, maybe this is it. Tap to unmute.
Hey guys, so Mr. B here again, and in this video I'm going to give you guys a way of remembering your trig derivatives. See if I can spell derivatives right, I never can. Alright, so I'm going to give you guys a way of remembering your trig derivatives. So we always remember the easy ones, easy two, right? So the derivative of cos of x is negative sine x, and the derivative of sine x is cos. It's the other ones that always cause people issues, and those are the derivative of secant, derivative of tan, cosecant, and then cotan. So I was trying to come up with something with my students to try and help them remember them for their calculus placement test, and what I came up with, or what they came up with, was this easy way of really remembering. So what they did was they wrote this quick little acronym. So they remembered secant, tan, and some of them like to put arrows on both ends. I'm not really good at drawing arrows, but there they are. So it kind of goes both ways. Secant, tan, and then cosecant, negative cosecant, and cotan. So they had secant, tan, cosecant, cotan. So you might say, well, that seems like it's hard to remember, but it's not. Secant and cosecant, tan and cotan. So these are I'll call them cousins, if you want to call them that way. These are both reciprocal functions, reciprocal of cos, sine, tan, and then reciprocal of tan is cotan. So it's easy to remember. Secant, tan, cosecant, cotan. So if you want to figure out what the derivative of secant is, then you just got to go secant tan. So the derivative of secant x is secant x tan x, just like that. So the derivative of secant is secant tan, and then the derivative of tan x is just go the other way. So secant times secant, which is secant squared x, just like that. So it works the same for this guy. So the derivative of cosecant is negative cosecant cotan. So the derivative of cosecant x, negative cosecant x, cotan x. And then lastly, we have the derivative of cotan of x. So the derivative of cotan is negative cosecant squared. So negative cosecant times cosecant is negative cosecant squared x. And there it is. That's the easy way how my students like to remember their trig derivatives in a pinch. Of course, you could just remember them. And that is it. Hopefully this helps you in some little way, guys. Conquer calculus. And thanks for watching, and I'll see you guys in class. Like, share, subscribe.